Hey everyone, we're going to do some mean value theorem homework. I only have a few minutes because of cold, but I wanted to at least get something down so that if you're struggling, you can check up on this on the internet. All right, so we're in 3.2 out of the problem book. I gave 687 and 694. Pick 4 of them. I'm just going to start at the beginning and see as far as I can get before the bell rings in about 5 minutes. So, all right. The following 8 problems verify the 2 conditions required by the mean value theorem, then find a suitable number C guaranteed to exist by the mean value theorem. So the mean value theorem needs to be, it just says this function needs to be continuous and differentiable on our interval. So continuous, it's a polynomial. And polynomials are continuous, so check there. Oh, and they're also differentiable. Just pretend that I finished that word. Okay, so mean value theorem says there is some instantaneous rate of change, some f prime at some x value c that is equal to the rate of change, the average rate of change over this interval. So if I were to find f of 3 minus f of 1 over 3 minus 1, whatever I get there, I need to find when f prime is actually equal to that average. And so let's see, f of 3, well that's going to be 4 times 3 squared minus 3 minus 6 minus f of 1. Now it's important to put parentheses there so you don't mess it up. So 4 times, I said f of 1, okay. 1 squared minus 1 minus 6 all over 3 minus 1, that's just 2, so I'm going to write that now. So let's see. 4 times 9 is 36, minus 3 minus 6, that's minus 9, okay. And this is 4, minus 7, that's negative 3. So minus negative 3 is a plus 3. That's a 39. I did the 36 and 3. I got 30 up here over 2. So I want to find out if this is my average rate of change, if 15 is my average rate of change, when does f prime equal my average rate of change? Well, remember, f prime, if f of x is equal to 4x squared minus x minus 6, well then f prime is just 8x minus 1. So I'm really trying to find when does 8x minus 1 equal 15? Well, that's really nice, isn't it? I'll just add 1 to both sides. I'll get 8x is equal to 16, so x is equal to 2. So I can say C is 2. The C that's guaranteed to exist by the mean value theorem is equal to 2. And if we were to double check this and we plug 2 into here, into my f prime, you'll find that 2 times 8, that's 16, minus 1, that's 15. That's our average rate over that interval. So that's all that's happening here. This is the basic idea. This is the calculus. The calculus is you find the average and you set the derivative equal to it and you find out that number that makes them the same. That's the C value guaranteed. So remember, this is our instantaneous, this is our average. And mean value theorem says if f is continuous and differentiable, we need both of those. So this is our if. As long as that's true, then the instant equals the average at least once. So the instantaneous rate of change is equal to the average rate of change at least once. And we call that C. At least once at some x equals C. So I found the at least once. Sometimes it's more than once, but this is kind of a distillation of the entire lesson that we looked at last time. I'm glad that this was our first example because it was really straightforward. If I have more time at some point, I'll come back and do more of these. All right, hope you all have a great day.